So quantum mechanics, the normalization constants. Okay, this is very important. Yeah. So wave function. Now we have some wave function psi is equal to psi of x or x comma t. Now this is some normal wave function. Okay, this is some wave function. Now what do you mean by a normalized wave function? Normalized wave function means the wave function psi, when you integrate from the limits, that means from x1 to x2, psi star psi dx, if it is a function of x alone, psi star psi dx should be equal to 1. That means the probability of the wave function is 1. Only then it is called normalized wave function. Now for example, if your wave function psi star psi integrated over the x1 to x2, which is the limits of the wave function or the domain of the wave function, times dx is giving you, for example, 2. Okay, then what you have to do is you have to divide this by 2, and here also you have to divide it by 2, which means in effect you are dividing the wave function psi to psi divided by root 2, because here you have psi star psi. This will be like integration from x1 to x2 psi divided by root 2 star psi divided by root 2 times dx. So this will give me 1. So I had a wave function psi which was not normalized. Okay, it is not a normalized wave function. Then what I did, I integrated. This is called a square integrable. The previous class we have discussed about this. This square integrable wave function, when I did, I got 2 as the probability, but 2 cannot be the probability because the maximum probability should be equal to 1. So I divided by 2. Then psi, which is not normalized, then what I did, I divided by root 2, so that I got a normalized wave function. So this is nothing but normalized wave function. Now this normalized wave function is also called wave packet. Wave packet means it will be something like this. This is from our first class of introduction to quantum mechanics. This is the maximum probability, this is the minimum probability, these two ends. Those who have not got the videos on in quantum mechanics, kindly go to our Telegram and WhatsApp group. You will find it there, or still if you are not able to find, please message me personally. I will send you the link. Okay, so now what is this wave packet? Wave packet is defined in this region. This is your x1, this is your x2, and this product is called psi star psi. Okay, yeah. So normalization 1D box. Now a few things. If psi is real number, then psi star psi will be equal to mod psi square, because what is star? Star is complex conjugate. If you have a wave function which is real number, it's a star, that means complex conjugate will be equal to the real number, right? Similarly, psi, if it is a real number, then it's a psi star, that means its complex conjugate will be also equal to a psi. Okay, now this is one thing that you have to remember when you are doing problem with normalization. Generally, if the wave function is defined in the interval minus infinity to plus infinity, you have to put it like this: psi star psi is equal to mod psi square. If you want to integrate from along x, this is okay. Now coming to one dimensional box, 1D box. 1D box has the dimension is 1, and generally if it is taken from in the x axis. Okay, it is taken in the x axis. Now let us write the domain or the limit of the wave function. Limit is from where to where? 0 to L, this is one thing, or minus L by 2 to L by 2. It is the general domain. Okay, it can be anywhere, but usually it is given in the form of 0 to L or minus L by 2 to L by 2. What is the total length? Total length is L. In this case also the total length is L. This is called unsymmetric 1D box, and this is called symmetric 1D box, one dimensional box which is symmetric. Now because why it is symmetric, I will tell you. This is going from 0 to L, and this is going from minus L by 2 to L by 2. Now somewhere here you will have 0. This is symmetric because in this length is same. From 0 it is defined. Now what is the wave function psi? Psi is equal to, we don't know, some a, that is some constant a, into sine n pi x by L. And what is this n? N is the order, L is the length of the box, and A is called normalization constant. Now our aim is to find A. Now how do you got this sign? Because in 1D box our wave function psi is a sinusoidal function. This we will discuss when we are discussing Schrodinger equation. Okay. Yeah, so let's come to the problem. One dimensional box. Let me draw the box. I am first taking the unsymmetric box, which 0, here you will have L, and I am writing the inside this you have the particle, whatever particle you have, and this particle has a wave function psi, and this psi is equal to, we know it is a sine n pi x divided by L, and this a we wanted to find. And what is the where I can find the particle? I can find the particle from 0 to L. So 0 less than or equal to x less than or equal to L. That means I am finding the particle, this x, at some point x, which will be always between 0 and L. Now the normalization, how we are finding the probability, that is integral 0 to L psi star psi dx should be equal to okay, this should be equal to 1, but let us see what is equal to, because it depends on the value of a. Now let us find what is psi star psi. This wave function psi a is a real number, sine is again a real sine of some constant is again a real number. So psi is a real number, so psi star psi will be equal to the psi square, mod psi square. So it is integral from 0 to L a square sine square n pi x by L dx. What is the value? This value should be equal to 1, right? Now a square you can take it out because a is nothing but it's a constant. So a square integral sine square n pi x divided by L dx should be equal to 1. Now I wanted to change, this is from 0 to L. Now I wanted to change this sine square. Now I can write sine square x equal to 1 minus cos 2x divided by 2. 1 minus cos 2x divided by 2. But in the previous class I have already told you sine square integral from 0 to L is nothing but half into length of the interval, half into length of the interval, if this is a half limit or full limit, half limit or full limit. Okay, but if you don't remember, you can use this formula. So this is equal to a square integral 0 to L sine instead of sine I need 1 minus cos 2 into n pi x divided by L, from where to where 0 to L times dx. Now this is equal to a square into first term integral dx 1 into dx from where to where 0 to L minus integral cos 2n pi x by L 0 to L. Now this term cos from 0 to L, you can just put the two limits. This integral cos is nothing but sine. This is a square into x from where to where 0 to L minus integral cos is nothing but sine 2n pi x by L into this is integration constants. You have to multiply by the constants 2 pi x by L. Now see this sine value is from 0 to L. If you put 0, sine will become 0. If you put L, it will become sine 2n pi. Sine 2n pi is equal to 0. So 0 and 0. So this entire term will get to 0. Now only thing that remains is the first term. So it will become a square into L. And one more thing, here we have sine square is equal to 1 minus cos 2 x by L. X by 2 is there, right? So I have to divide by 2 here because this is I am replacing sine square. So sine square I have to multiply by 1 by 2 here, 1 by 2, 1 by 2 and 1 by 2. no, I just forgot to write it. You just, so 1 by 2 a square L equal to 1. Now what I want to write, find a square is equal to L by 2, a is equal to L by 2 under root. Fine. So the wave function psi is equal to under root 2 by L sine n pi x by L. Now you can also remember this is for wave function of order n. Psi n is equal to 2 under root 2 by L sine n pi x by L. So this is the wave function for 1D box, normalized wave function for 1D box. Now there is a small shortcut. Now for the exam purpose you need not do all the things. This is only for those wave functions we don't know. You can follow these steps, but for 1D box, for that means for general models, general models like 1D box, 2D, 3D, we have the already defined formula. So if 1D box is a sine n pi x by L, you need a, right? So just check from where to where it is defined, 0 to L. That means you need length of the box. Okay, only thing that you need in a one-dimensional box to find out the normalization constant is length of the box. So a is equal to, or normalization constant is equal to, a is equal to under root 2 by length of the box. Okay, now suppose the question psi is equal to a sine n pi 2 n pi x by L. Now can you tell me what is the normalization constant A? Now you see 2 here, I should write it as a sine n pi x divided by L by 2. Here length of the box is L by 2. Then normalization constant A will be equal to under root 2 divided by, what is the length of the box? L divided by 2. So this will be equal to under root 4 divided by L. Okay, so likewise you can find out the normalization constant. Only thing is needed is length of the box. Once you have the length of the box, your normalization constant is ready. So exponential wave function is psi is equal to psi e to the power minus a mod x. This is of the form exponential wave. Now we don't know the normalization constant, so I am just writing a in the beginning, so that it becomes psi is equal to a psi e to the power minus a mod x. Okay, so this is my normalization constant. So what I have to do in the beginning, so minus infinity to infinity e to the power minus a mod x into a square, or I can write a square here, a square e to the power minus a mod x into psi star psi, right? So instead of that, e to the power minus a mod x. Now both this is a real function, right? It's a real function dx. So this we can write it as a square. Now we have to integrate from where? Minus infinity to plus infinity. e to the power minus 2a mod x, 2a mod x dx. Now a square into now whatever you are seeing on this function, that means e to the power minus 2a mod x, this is an exponential function. Now this is exponential function is a even function. Now what is the peculiarity of even function? If you have a function, this f is an this is from minus L to plus L. If this function is even function, then I can write it as integral 0 to L 2 times f of x dx. This is the peculiarity of even function. Now a square into 2 into integral, instead of minus infinity to infinity, I can integrate from 0 to infinity e to the power minus 2a. Now I need not mention the mod x because I had defined the interval in the positive region, so I need to write only x times dx. So this is will be equal to a square into 2 into e to the power minus 2ax, 0 to infinity e to the power minus 2x. This integral we have already done that, it is equal to 1 by 2a. Integral 0 to infinity e to the power minus ax is equal to 1 by a, 1 by coefficient of x. Please remember all the integrals that I have given you. A square into 2 into 1 divided by 2a. So that's equal to 2 gets cancelled. It is equal to a square divided by a. Now this is the norm integral. This integral probability, that is a square divided by a, is equal to 1, which means capital A square is equal to root of a. And what is this a? A is nothing but the coefficient of mod x. So for, wait, this is not a square, this is a equal to root of a. So the wave function psi is equal to, we have psi e to the a e to the power minus a mod x, which means a is equal to root of a. That means psi is equal to root of a e to the power minus a mod x. Now this is the normalization constant for exponential function. Exponential function e to the power minus a mod x. Normalization constant a is equal to root of a. Please remember. The wave function psi is given by a e to the power minus a mod x into e to the power ikx, e to the power ikx. Find the normalization constant a. Now the interval is defined as minus infinity to plus infinity. That means this particular wave function is defined in the region minus infinity to plus infinity. Integral minus infinity to plus infinity mod psi square dx. Now what is this mod psi square dx? This is integral minus infinity to infinity psi star psi dx. Now since this wave function is complex, our psi star psi is not equal to psi, that means the square integral, you will have a minus term. So psi is equal to a e to the power minus a mod x into e to the power I k x. Psi star is equal to a e to the power minus a mod x into e to the power minus I k x. This is psi star. Now what is psi star psi? E to the power I k x and e to the power minus I k x. E to the power a into e to the power b is equal to e to the power a plus b. So e to the power a is here, this is e to the power b, so minus ikx plus ikx, that will give you 0. So that will be equal to a square e to the power minus 2a mod x, right? Psi star psi we got. Now the rest is what we have done so far. Integral minus infinity to plus infinity a square e to the power minus 2a mod x dx. Now since this is an even function, you can write it as a square into 2 into 0 to infinity e to the power minus 2a, instead of mod x just write x times dx. Okay, so this is as usual 2 times a square, and what is this integral? This is nothing but 1 by 2 times a is equal to 1, because the integral should give you a value equal to 1. So 2 gets cancelled, a square is equal to a is equal to root of small a. Okay, now there is a note, that kindly note, complex terms do not participate in integrals, in square integrals. In square integrals, that means psi star psi. Okay, in normalization, when you are doing problems with normalization as well as probability, do not consider complex exponentials. Okay, for example, e to the power I k t, e to the power I minus I px, something like this. Okay, these kind of terms you can eliminate. Yes, friends, before going to the next question, VK Lectures has got something for you. We are doing CSIR net classes for about 12 months, and we will have around 300 hours of class. And for PhD students, faculties and working students, recorded classes of our video will be given to you in the link, YouTube link mainly. And in the this 12 months duration, we will be solving around 3000 problems in the class, and we will almost have around 60 test papers. Weekly exams will be conducted through Google Form, and we will also have question solving sections after the exam. Class timings will be from 7 to 8:30 p.m. from Monday to Friday, and this will be conducted online through Google Meet. The class will have the course will have the fee structure of 20,000, and the first 5 admissions will be giving 40% discount. That means the first 5 admissions need to pay only 12,000, and the next 5 admissions will be given 25% discount, which is 15,000 rupees. Now, what extra materials VK Lectures is providing you? is around 50 plus ebooks for reference, and if students require only some particular subjects like quantum mechanics, you will be given 40 to 50 lectures of quantum mechanics, and the regarding test papers and corresponding materials will be given. And for lecture series, uh, that means per subject you may have to pay 3500. And yeah, so that's about our course. For details you can contact, either you can use our Gmail, or you can use our Telegram channel or WhatsApp channels for that. Thank you, and we will see the next question. The normalization for Gaussian wave function. Now Gaussian wave function is of the form psi is equal to a e to the power minus half ax square. It should be of this form. It need not be half, anything, or a e to the power minus ax square, some constant into its the square of the dependent variable, okay, independent variable. So this is an example of Gaussian wave function, and when you are drawing the wave function, it will be something like this. Okay, this is from minus infinity plus infinity, this is a 0. Okay, now okay, so let's take psi is equal to some constant a e to the power minus alpha x square. So this is an example of a Gaussian wave function. Now I am integrating from where to where. It is to be integrated from minus infinity to plus infinity. Mod psi square dx is equal to 1. So that's equal to integral minus infinity to plus infinity psi square, that is a square e to the power minus 2 alpha x square. Now why 2? Because it's squared. This is a real function. Right. So this value dx, if you do, that should be equal to 1. Now a square minus infinity to plus infinity. Okay, so a square you can take it out. Integral minus infinity to plus infinity e to the power minus 2 alpha x square. Okay, in the previous class we have done the integral, that is integral from minus infinity to plus infinity e to the power ax square dx. That's equal to under root pi divided by a. Under root pi divided by a, that is from minus infinity to plus infinity. So this is equal to a square integral minus infinity to, okay, so leave this. You can immediately write root of pi divided by, instead of a, here it is a coefficient of x square. Here the coefficient of x square is nothing but 2 alpha. So under root pi divided by 2 alpha equal to 1. So what is a is equal to? A is equal to 2 alpha by pi whole to the power 1 by 4. This is pi divided by 2 pi whole to the power 1 by 2. So a, that is a square. So a will be equal to 2 divided by 2 alpha by pi whole to the power 1 by 4. So our wave function will be equal to psi is equal to under root 2 alpha by pi e to the power minus alpha x squared. So this is the wave function for Gaussian function. That is nothing but linear harmonic oscillator wave function. This is a wave function for linear harmonic oscillator LHO, one dimension. Fine. Now for same linear harmonic oscillator, let me introduce you to another kind of wave function for the similar wave function, that is psi is equal to a e to the power minus half alpha square into x minus a whole square. Now here you are asked to find the normalization constant a. Now here also you need not do anything else, you need not go for this psi star psi dx integral equal to 1, that is defined from minus infinity to plus infinity. Immediately what you have to do is find a is equal to root of, or take the coefficient of this entire term, okay, coefficient of this entire term, that is alpha square divided by pi whole to the power 1 divided by 4. Now this wave function is nothing but Gaussian wave function, but here is a small difference. In the previous example we had psi is equal to a e to the power minus half alpha square into x minus 0 whole square, because it is equal to a e to the power minus half alpha square x square. I am just writing this x as x minus 0. Now this 0 represent the center of the Gaussian function, center of Gaussian function. Only that in the beginning we had the Gaussian function like this, here x equal to 0, that means maximum here, and in the second case we had the Gaussian function something like this, okay. This became the center, that is here x equal to a. This is the second wave function. This is if I am writing this as second wave function, this is psi 2. Earlier it was at x equal to 0, now it is slightly changed, but even if there is a slight change, that means shift. If there is a shift in wave function, shift in position, there is no change in normalization constant. Quite a number of questions have you can get by replacing the wave function with some slight modification, but even then our normalization constant will be same if there is only shift, okay. If there is another serious change in the coefficient of these things, then there can be a change, but the normal formula remains same. Only thing is you need to remember, you should know this what kind of wave function it is. You should know it is Gaussian and the limits from must be from minus infinity to plus infinity. Then there is no change in the normalization constant. You can immediately write the normalization constant and find the whatever required things. It can be probability, it can be energy, anything. Now the wave function psi is equal to a sine kx divided by x. Now for this kind of problems, what you can do is immediately put kx is equal to some constant, some t, not a constant, some t, because we can get we can write this x in terms of some other. Okay, this is the only reason. Now kx equal to t means I can write k dx is equal to dt, and dx is equal to dt by k. Okay, fine. Okay, so integral psi star psi, integral psi star psi, I can write it as and the limits, this limit is from minus infinity to plus infinity. Okay, this is the limit of the wave function psi. So psi, okay, this is a square, then sine square kx divided by x square dx. This is from minus infinity to plus infinity. So let's rewrite this. A square integral minus infinity to plus infinity sine square, instead of kx I have t, so sine square t divided by x square. This x square becomes x square becomes a t square by k square. So here I will write t square, here I will write the k square, and what is dx? Dx is nothing but dt by k, so dt divided by k. Now okay, fine, now everything is sorted out. This is of the form a square, this k square get cancelled, so I can write k here, integral minus infinity to plus infinity sine square t divided by t dt. Now yesterday, or that means when we are discussing the integrations from mathematical methods, we have seen integral from minus infinity to plus infinity sine square x divided by x. Sorry, this is t square, square x by x square is equal to pi, and integral minus 0 to infinity sine square x by x square is equal to pi by 2. Okay, so that's integration constants. So a square k sine square t by t square is equal to pi, and this should be equal to what? Integral minus infinity plus infinity should be equal to 1. This should be equal to 1. So a square is equal to 1 divided by pi times k, which means a is equal to under root 1 divided by pi k. And now what you have to do is you have to just substitute this a here. What? A square. So psi is equal to 1 divided by under root pi times k into sine kx divided by x. So this is the wave function. Psi is equal to the normalization constant a divided by root of x square plus a square e to the power I k x. Now you are asked to find a, and the limit is from minus infinity to plus infinity. In some questions, if the limits are not given, you can take it from minus infinity plus infinity. Okay, if the limits are not given. Okay, so mod psi square dx. Now this term which is complex, its conjugate will be e to the power minus ikx, and this will be equal to 1. Its psi star psi will be equal to 1. So I can write this is equal to, the total integral should be equal to 1. So that's a square divided by x square plus a square integral from minus infinity to plus infinity times dx is equal to 1. Fine. So this is nothing but the integral. Okay, take this a square out, integral minus infinity to plus infinity 1 divided by x square plus a square dx. Now 1 divided by x square plus a square integral 1 divided by x square plus a square is equal to tan inverse x by a into 1 by a. So 1 by a tan inverse x by a. So that is the integral. This is tan 1 plus x by a whole square. So that is equal to 1 by a tan inverse x by a. So that's equal to a square into 1 divided by a tan inverse x by a. This is from minus infinity to plus infinity. So tan inverse x by a at minus pi by 2 is at pi by 2, sorry, at infinity, tan inverse infinity is pi by 2, a square into 1 by a tan inverse infinity pi by 2 minus tan inverse minus infinity minus pi by 2. So both it will get added, it will become pi. So that's equal to a square into 1 by a into pi is equal to 1. So a square is equal to 2 by pi, and a is equal to under 2 by pi. Okay, so what we have to discuss? Yeah. So just a recap of what we have done so far in the normalization session. First one was the 1D box, one-dimensional box. The wave function is of the form psi is equal to a sine n pi x by L. Then where L is the length of the box, n is the order of the state. Okay. Now normalization constant a is given by under root 2 divided by length of the box. Length of the box. Under root 2 divided by length of the box. Okay, do not touch anything else, don't try to do the integration, nothing, just simply a is equal to 2 divided by length of the box whole to the power 1 by 2. Okay, now second one that we have discussed is exponential. Psi is equal to a e to the power ax. This will be in the interval 0 to infinity, or sometimes a e to the power ax. Then this will be in the interval minus infinity to 0. Okay, for both a is equal to root of coefficient of x. Okay, then the third one, the harmonic wave function. that is linear harmonic oscillator. The wave function is of the form Gaussian function. Gaussian.
So that
Yes,
is
please.
cos of what?
So the third one, linear harmonic oscillator, the wave function psi is equal to a e to the power minus alpha x square. So the Gaussian function, the graph will be something like this. It's in. Okay. So what is the normalization constant A? A is equal to pi divided by alpha whole to the power 1 by 4. And just let me confirm that. Sorry, 2, okay, so it's not this one. 2 alpha by pi whole to the power 1 by 4. Now what is this alpha? Alpha is nothing but coefficient of x square. What is here? Okay, coefficient of x square. Okay, so this is for linear harmonic oscillator. Now yesterday we did few problems, we'll see. Okay, just we'll write it once again. Psi is equal to a e to the power I k x plus rx and a e to the power I k x minus rx. This is in the interval x less than or equal to 0, and this is where x greater than 0. Now how will you find out the normalization constant? Is from minus infinity to plus infinity, psi square is nothing but psi star psi equal to 1. What is psi square? It should be equal to psi star psi. Okay, now let's see this. Just splitting the integrals, I'm going from minus infinity to 0. So minus infinity to 0 means x less than 0. In the interval x less than 0, you have psi square as a square e to the power ikx into e to the power rx. Just splitting. So its complex conjugate will be e to the power minus ikx into e to the power rx. So this first term will get equal to e to the power 0, which becomes 1. So e to the power rx into e to the power rx, it will become e to the power 2 times rx. So e to the power 2 rx dx plus integral. Now we are going from 0 to infinity, as a square is there. Here you have e to the power minus 2rx, because here you have minus sign. Now this 0 to infinity, now a square you can take it out, a square integral e to the power 2rx from minus infinity to 0 is 1 divided by 2r. This is the integral that we have done earlier. So this is a square. Again, the integral has changed the limits, and by changing the limits there is corresponding change in the exponential term, so it becomes minus. So this is also equal to 1 divided by 2r. The total should be equal to 1. So a square, when you take it out, this is half 1 by r, this is half 1 by r. So together it will be 1 by r. So that is equal to 1. So a square is equal to r, which means a is equal to root of r. So the normalization constant A is equal to root of R. Psi is equal to A x divided by small letter a from the interval 0 less than or equal to x less than or equal to a, and the another value of the wave function is a into b minus x divided by b minus a. This is in the interval a less than x less than b. Now there are two regions. One is from 0 to a. That means if you have the something like this, this is 0, this is a, and somewhere here you have b. So 0 to a you have one wave function psi1, that is this one, and from a to b you have another wave function which is psi2. Okay, the process are same. The integral from 0 to a psi 1 mod square plus integral a to b psi 2 mod square dx should be equal to 1. So how can you write that? So this is when you square this, it will become a square divided by small letter a square. So this is capital A square divided by small a square, integral from 0 to a x square dx, x square dx plus integral a to b. This again term, this is a square divided, again this can be taken out, b minus a whole square into b minus x whole square dx. This is from a to b, the first one is from 0 to a. Now let us write down the first one. So a square divided by small letter a square x cube by 3, from where to where? 0 to a. Okay, that part is being done. Now you have a square divided by b minus a whole square, then let it be outside, b minus a whole squared into integral from a to b, b minus x whole square. Actually we can integrate here itself, that will be equal to b minus x whole cube, b minus x whole cube divided by 3 into minus 1 integration, right? So the entire part you can write it as from a to b. Fine, b minus, yeah. Now a square divided by, let's write down the first term and get the constants. A square divided by capital A square divided by small a square into x cube. When you put the upper limit, it becomes a cube by 3. So this is a cube by 3. So in general you can cancel out a and a square, so it becomes a square a divided by 3. So this is the answer for the first term. Now let us see the second term. So a square minus b minus a whole square into, with a minus sign. If you have a minus sign, put the lower limit first and then the upper limit. Okay, first put the lower limit first and then the upper limit. Okay, so I am putting the lower limit, so it will become b minus a whole cube by 3 minus b, that is equal to 0, right? I need not write anything there. Okay, fine. So this becomes a square divided by b minus a whole square into b minus a whole cube by 3. Again here you can remove this, this is square and this is cube, so in effect you will have a square divided by 3 into b minus a. Okay, so this is our first term, and this is the second term. Add both, what you will get is a square divided by 3 into a plus b minus a. So minus a get cancelled, so it becomes a square divided by 3 times b should be equal to what? Should be equal to 1, and what you have here, a square b, you are asked to find out a square, which is equal to b by 3, and a will be equal to under root b by 3, or it's under root 3 by b. Yeah. Okay, hydrogen atom. Okay. So hydrogen atom is a 3-dimensional model. Atom is a 3D model, and when you are finding the normalization constant, or the wave function is defined in 3 dimension, x, y, z, but when you are doing the hydrogen atom problem, it is easy to work with spherical polar coordinates, that is r, theta and phi. So the normalization constant, it will be integral mod psi square d tau or dv. Okay, integral psi square dv. Now in dv in Cartesian coordinate system, we can write dx, dy, dz, but in spherical polar coordinates you can write dv as r square dr, there is no comma, into r square dr sin theta d theta and d phi. Now it is also important to know the limits of r, theta and phi. R limit is from 0 to infinity, theta from 0 to pi, and phi from 0 to 2 pi. You must remember this. Okay, yeah. So hydrogen atom in general form is given by psi is equal to a e to the power minus r divided by a naught, where a naught is Bohr radius or ground state radius. Okay. Now integral, the different terms are right, so I am simply writing integral psi square dv is equal to a square, that is this a square, into e to the power minus 2r divided by a naught, into, we need dv, right, so that is r square dr sin theta d theta d phi. Now one more thing, this is e to the power minus 2r by a naught r square dr, and these are other integrals. This is from 0 to infinity, this is from theta from 0 to pi, and d phi from 0 to 2 pi. Now our wave function psi is a function of r alone. You can check it doesn't depend on theta and phi. So since psi is a function of r alone, you can integrate it directly, sin theta, d theta and d phi. And this particular integral sin theta d theta and integral d phi will give you a value equal to 4 pi, because this phi from 0 to 2 pi is 2 pi, and this sin theta from 0 to pi is 2, so 2 pi, that is 4 pi. So our equation reduces to a square into 4 pi into integral from 0 to infinity e to the power minus 2r divided by a naught into r square dr. Okay, now here you have a function, that means the integral, the basic integral from 0 to infinity x to the power n into a to the power x, sorry, yeah, x to the power n, a to the power x is equal to that is given by n factorial divided by a to the power n plus 1, n factorial divided by a to the power n plus 1. Now in this equation, what is x to the power n, that is, this is x, this is n, so 2 to the power r to the power 2, so x to the power n means n value is 2, so that will be equal to 2 factorial. And what is a equal to? A is equal to 2 divided by a naught, so that is 2 divided by a naught. Into whole to the power n plus half. What is n? N is equal to 2, so 3. Okay, so this entire integral will be equal to 2 factorial by 2 to the power a naught whole to the power 3. So that is a square into 4 pi into 2 factorial, that is 2, divided by 2 to the power 3 into a naught cube should be equal to what? 1. So a square is equal to, bring all the other terms to the denominator, the other side, 1 divided by 4 pi. This is okay, we can cancel out all these terms, into 4 divided by a naught cube. Okay, that is equal to a square. So a is equal to 4 and 4 get cancelled, that is 1 divided by under root pi a naught cube. The formula was integral 0 to infinity x to the power n into e to the power minus ax dx is equal to n factorial divided by a to the power n plus 1, n factorial by a to the power n plus 1. Okay, and what is the integral from 0 minus infinity to plus infinity? E to the power minus ax square dx, that's equal to under root pi divided by a. Okay, yeah. Okay, one more thing. This is usually used in the case of hydrogen atom. This is linear harmonic oscillator. And again one more similar type of linear harmonic oscillator type problem is integral minus infinity to plus infinity x to the power 2n into e to the power minus ax square dx is equal to root of pi into 1 into 3 into 5 into up to 2n minus 1, up to 2n minus 1. You just have to multiply these numbers, that means odd numbers up to 2n minus 1 divided by 2 to the power n, 2 to the power n into a to the power n plus half. All terms are given here. N is the power 2 to the power n, a is coefficient of x square, a to the power n plus half in bracket. Yes, friends, before going to the next question, VK Lectures has got something for you. We are doing CSIR net classes for about 12 months, and we will have around 300 hours of class. And for PhD students, faculties and working students, recorded classes of our video will be given to you in the link, YouTube link mainly. And in the this 12 months duration, we will be solving around 3000 problems in the class, and we will almost have around 60 test papers. Weekly exams will be conducted through Google form, and we will also have question solving sections after the exam. Class timings will be from 7 to 8:30 p.m. from Monday to Friday, and this will be conducted online through Google Meet. The class will have the course will have the fee structure of 20,000, and the first 5 admissions will be giving 40% discount. That means the first 5 admissions need to pay only 12,000, and the next 5 admissions will be given 25% discount, which is 15,000 rupees. Now, what extra materials VK Lectures is providing you is around 50 plus ebooks for reference, and if students require only some particular subjects like quantum mechanics, you will be given 40 to 50 lectures of quantum mechanics, and the regarding test papers and corresponding materials will be given. And for lecture series, that means per subject you may have to pay 3,500. And yeah, so that's about our course. For details you can contact, either you can use our Gmail, or you can use our Telegram channel or WhatsApp channels for that. Thank you, and we will see the next question.